Hello everyone and welcome back to exercise number 34 of the SolidWorks basic tutorial series. In this video, we're going to be designing a circular mounting flange. Now, as always, in designing this part, we're going to be using many of the SolidWorks features, such as the extrude boss base feature and extrude cut feature. But as we will see later on in this video, we're also going to use the circular sketch pattern tool very heavily. Here we see this schematic drawing for exercise number 34. All dimensions here, of course, are in millimeters. We have the isometric view, the top view, and the section view, and the section view is taken along this horizontal line here. Looking at the main features for the component, of course, we have this main cylindrical body. In addition to the opening here at the top of this recess, we also have a central bore here, in addition to 3 mounting holes on this top face right here. Also, please notice that we have this notch, 4 of them actually, and this notch is actually 10 millimeters wide and 10 millimeters deep. Also, we have 3 mounting lugs. So it's sufficient that when inside SolidWorks, it's sufficient that we only model or sketch out one of the lugs. We'll sketch for one of the lugs and then use the circular sketch pattern tool to create the other 2 copies. Here we can see the instructions for this practice problem. Here, step number 1 is for you to open your 3D CAD system, either using SolidWorks, Fusion 360, or Onshape, it doesn't matter. Step number 2, of course, is to design the component to scale using the dimensions shown in this figure here. And of course, we need to assign a material for this component. And here we're going to use ASI 1020 steel, okay? And finally, as you can see here, there's a question at the bottom that says, what is the mass of this part in grams? Of course, we have a tolerance of plus or minus 1 gram. So the main question here is to fully sketch this model and determine the mass of this part, or how heavy it is. All right. And you can see here, step number 4 involves calculate the mass of this part rounded to the nearest gram right here. Okay. So that is exercise number 34. And actually, we can do this in 4 main steps. Again, this is following a feature-based approach. Step number 1 is to sketch out or to model the main body of the component, including the top recess here. Step number 2 is to create the central bore along with the 3 mounting holes on this top face. And step number 3 involves creating these 4 notches here. And step number 4 involves creating the lugs for the component. Okay, so with that aside, let's get started with exercise number 34. Okay, so let's start by creating a new SolidWorks part. We set the background to plain white, and we copy exercise number 34 into SolidWorks. As I said previously, we can model this in 4 main steps, and step number 1 involves creating this main cylindrical part of the body. But also, please remember that the reason why we're modeling this within SolidWorks is to determine the mass of the component. Right here it says, what is the mass of this part in grams? And of course, we have a tolerance of plus or minus 1 gram. So to do that, we need to first model the component in its entirety, including all of its main features and assigning the dimensions. After that, we need to determine or assign a material for the component. Here it says that we should use the ASI 1020 steel. And then we can determine the mass of the part. Okay, so let's start with step number 1, creating the main cylindrical body of the component. So select top plane, sketch. Let's put this to the side right here. And of course, the cylinder here starts with a circle, right? So we sketch a circle starting from the origin of the component. So select circle, and starting from the origin, we draw a single circle. Looking at the top view here, we see that this larger circle has a radius of 55 millimeters. So go ahead and activate the Smart Dimension tool by pressing the right mouse button on your mouse, and then move your cursor upwards to activate the Smart Dimension tool. And assign a diameter of 110 millimeters. Okay? Now we need to extrude the sketch, so press S on your keyboard, and then select Extrude Boss Base. And from the figure here, we see a section view for the component, and the overall height of the component here should be 36 millimeters, okay? So go ahead and assign a extrusion height of 36 millimeters, and then select OK. Now we need to create this opening, this recess at the top. So to do that, select this top face, sketch. Again, we select circle, and starting from the origin, we draw a single circle, okay? And from the figure, we see that this circle should have a radius of 48 millimeters. So activate the Smart Dimension tool and assign a diameter of 48 times 2, right, which is 96. Now we need to cut out this circular sketch to a depth of 23 millimeters, as shown here within the section view, to create the opening or recess at the top. So press S on your keyboard and select Extrude Cut. And assign a cut depth of 23 millimeters. Again, this is according to the figure, 23. Okay, that completes step 1, creating the main body of the component. Now we need to work on creating the holes in the middle here. Specifically, we have this center bore and then these 3 mounting holes. So to do that, select this face, sketch, select circle, and starting from the origin, we'll draw a single circle. This circle here corresponds to the central bore of the component. And here we see that this circle should have a diameter of 32 millimeters. So activate the Smart Dimension tool and assign a diameter of 32 millimeters. All right. Now we need to draw another circle. So select circle and starting from the origin again, we draw another larger circle this time. And we need to convert this circle to a construction geometry. So select the circle and then select construction geometry. Now this circle is the construction geometry. This circle here corresponds to the PCD or pitch circle diameter that we see here. And we have a diameter of 64 millimeters. So let's go ahead and assign a diameter of 64 millimeters for this circle. Select circle again, and let's go ahead and draw this top circle starting from this point here on the PCD. So draw a single circle, and the circle here has a diameter of 22 millimeters. So select Smart Dimension and assign a diameter of 22 millimeters for the circle. But also notice here that we have 2 other circles, and these 3 circles are equally distant from each other. So we can just save time and select Circular Sketch Pattern. Here's going to ask you for the entities to pattern. So select this circle, and we have 3 copies in total. Okay, and then select OK. Now we need to cut out these 3 holes to the other side of the component to create the openings. So press S on your keyboard, select Extrude Cut, set the end condition as through both directions, and then select OK. All right, so that creates the 4 openings for the component. That's step 2. Step 3 involves creating this opening, this notch here for the component. You have 4 of them, of course, so it's sufficient that we only do 1 of them and then use the Circular Sketch Pattern tool to create the other 3 copies. So let's select this top face, sketch, let's select center rectangle, and let's draw a rectangle here. Make the relation between the center of this rectangle and this origin as vertical, so it doesn't move to the side. This rectangle doesn't move to the left or right. It's directly overhead of the origin. And select Smart Dimension, and we can see here from the drawing here that this notch here should have an overall length of 10 or width of 10 millimeters. So the length of this edge should be 10 millimeters. Now we don't need to define the length of this edge because the only dimension here that actually counts is the width of the opening and the depth. All right. So simply just press S on your keyboard, select Extrude Cut, and we're going to extrude this rectangular profile to a depth of 10 millimeters. Okay. So set the end condition as blind and assign a cut depth of 10 millimeters. So that creates one of the notches. But again, like I said before, we have 3 other notches that are equally distant from each other, equally spaced. So go to Features, go to Linear Pattern, and then select Circular Pattern. Right, here's going to ask you for the direction for this circular pattern. Simply select this circular profile here. And of course, it's already selected by default the last feature that you created, which is this Extrude Cut. And we need to create how many copies? 4 copies in total. All right, and then select OK. So that creates the 4 notches here, and that completes step number 3. Finally, we have step number 4, and that involves creating the lugs for the component. So what do? We select top plane, sketch, and the strategy here, like I said previously, is to draw only one of the lugs, the sketch profile of one of the lugs, and then we're going to use the circular pattern tool to create the other 2 copies. Anyway, so select circle, and starting from the origin here, move vertically downwards, and draw 2 concentric circles, 1 and 2. All right. Now set the condition for this circle, this center point, and this origin as vertical. Okay. So now the 2 points, the 2 circles here, are directly overhead of the origin of the component. The 2 circles are not going to move either to the left or right. So from the figure here, we see that this larger circle should have a radius of 10 millimeters, which corresponds to a diameter of 20 millimeters, and we have the inner circle with a diameter of 10. All right, so select Smart Dimension, and the diameter of this circle should be 20 millimeters, and the diameter of this smaller circle should be 10 millimeters. Also, notice here that these two circles lie on a pitch circle with a diameter of, let's see here, where is it? Here, 68 millimeters. So the radius, or the distance from the origin here to the center of these two circles should be 68 millimeters. All right. Now we need to close off the sketch for this lug feature. So simply select a line tool and then draw a line. So before that, let's actually select these three faces and select Convert Entities to sketch out the profile, and then connect this circle with this sketch right here. All right, trim entities, and let's delete this extra line at the bottom. Now we need to mirror this line to the other side for symmetry. So we'll go ahead and select center line, and from the origin here, draw a vertical line. Select mirror entities, and we're going to mirror this line here along the vertical line that we just created, and then select OK. Make the relation between this line and this line as equal. All right. And notice here from the figure that we have a angle between these two lines, and the angle is 30 degrees, right? So select Smart Dimension and assign an angle between this line and this line as 30 degrees. Now trim entities, and go ahead and delete any extra lines, leaving only the profile, the 2D sketch of this lug. So I'm going to delete these lines here and this circle right here. Okay, so select OK. Now we have the 2D sketch for this lug. Go to Features, Extrude Boss Base, select the sketch, and we're going to extrude this to a height of 14 millimeters, as you can see here from the section view. So go ahead and assign an extrusion height of 14 millimeters. All right. Now, of course, we have to round out certain edges. So go ahead and select Fillets. And for the first edge here, we have this edge right here. Okay. And you can see here that we have fillet radius of 3 millimeters. So go ahead and assign a fillet radius of 3 millimeters. Also, we have this top face should also be rounded out right here. And then select OK. So that rounds out the edges that we need for this lug feature. Now we need to copy this sketch, or this body we just created, to the other side here, using the circular sketch pattern tool, of course. So select linear pattern and select circular pattern. Here's going to ask you for the direction. Select any circular profile here. And here you can select the features that you want to copy. So select this circle right here, this tangent line. And yeah, that's pretty much it. And set the number of copies to 3, because we have 3 lugs in total. All right, and equally spaced. The condition here is set to equally spaced. Select OK. Okay, so now that completes the main task, which is to model this component. Let's go ahead and set the view to perspective. Now we need to assign a material for this component, and we can see here, according to the instructions, that we need to assign a material of ASI 1020. So here, go to Edit Material, and assign a material of ASI 1020. Apply, close. Let's add color to this component. Let's select orange. Let's change the saturation a bit. Then select OK. Okay, so finally now we're ready to determine the mass of this component. So simply go to the Evaluate tab. In case you don't have the Evaluate tab on SolidWorks, you can just simply right-click on the SolidWorks Command Manager, go to Tabs, and you see here that we have an option of Evaluate. You can click this to uncheck the Evaluate tab. So now I don't have the Evaluate tab. To reactivate it, right-click, Tabs, Evaluate. Okay. So select Evaluate, and here we see a tool called Mass Properties. And it says here that you can calculate the mass properties of a model, such as mass, volume, and surface area. So go ahead and select Mass Properties. And we have here a mass of 1300.69, all right? So that is the mass of this component. So that is the final answer that we have, 1300.69, or 1300.69 grams. Okay, so that concludes exercise number 34. I hope you all enjoyed this video. If you have any comments or questions, please leave it down in the comment section below. I'll see you all in exercise number 35. If you have any suggestions, please shoot me an email. Until then, bye-bye.